All right. Oh, well, I'm not on.
Laptop A.
Well, that's definitely not it, right? The other plug. All right, there we go. Make sure we're still recording. Yep. All right. So, first of all, something interesting that's going down today, if you're interested in seeing it, is after class today, I'll be going down to the field house where I'll be playing in a cricket tournament. As you might imagine, I'm extremely gifted at things that require base running, and once upon a time I was a pretty good first baseman, but that was many moons ago. But that'll be a interesting thing. Go ahead. To be honest, I did. I had a nickname. My in Little League, the nickname was Mike the Playground Littman. Is as I was one of the biggest kids in the littler, and so I would hit home runs pretty consistently because the fields were pretty small, so I'd hit it into the playground. So once we got out to when we moved to the larger fields, this was in Rantoul, Illinois. The league was called Sandy Koufax, which was, I think, probably like maybe 15-year-olds, something like that. Then the field was a lot bigger, and I hit some home runs, but I was not nearly as dominant. It is what it came down to. But I was pretty good at tennis in that former life. So I had big serves back when, so I hit maybe like 130 mile an hour serve, something like that in high school. But my second serve was the wicked one. I put a lot of kick on it and would have these kids flying into the fence trying to chase it because I'm left-handed, so I'd have opposite spin to what they're used to. All right, so let's go back. So obviously, last class we had a lot of practice working with the debugger. Um, Ultimately, trying to avoid what the solution, the easiest solution, ended up just being. But so I already have done it, so I'm gonna just show it to you real quick. This only took another minute and a half after class was over. So let me just show you the process. And it is related to what we're going to be working with moving forward anyways, because we'll probably do some simple little animation stuff. So we want to turn our mind back towards this idea of components. So if you remember last time, what I did was for each of our pellets, so we have a single dungeon room scene, and I put 4 pellets in there. I made a little script called pellet controller. And that script, it knows the direction of that particular pellet. So on the north pellet, it has the value north in there. The west pellet, it has the value west, so on and so forth. All right, so each individual pellet held onto a single string of what direction it's heading in. So we didn't have to utilize that moving direction in our singleton that we used to keep track of the direction we were coming into the room from. All right, so now with that in mind, and you had already seen something like this before, but it's been a little bit. When a object has a rigid body, you remember back from the tutorial, you were able to get the rigid body component of a game object and then do things to it related to direction or something like that. The same thing's true with any kind of component, including scripts. So let me show that to you. All right. So this is where we're ultimately going to be putting some code in, but let me get to, okay. So right here, I'm getting the current room like we had before. So this is our code where when we bump into a power pellet, we can visually make it disappear, but we also want to remove that pellet from this room programmatically. So I'm going to call my current room. I'm going to call my remove pellet, which is the same function we had before. For now, other, this is the thing we just collided with. So this is the trigger associated with our pellet. And I'm going to get a component from that pellet game object. The component I'm going to get is the pellet controller, which is its script. So what this is going to do is give me an instance of that class, an instance of that running script, which has a field, a public field called direction. So I can ask the game object script what the current value of that game object's direction is, which each pellet had a unique direction. And I can pass that into our remove pellet function. So I know I'm removing the pellet in the correct direction. Make sense? This is the more object-oriented way of doing it anyways. Where it gets a little funky is our pellet controller. Let me just show you that here real quick. So here's our pellet controller. Effectively, this guy is just a class with a field. But notice that this guy, first of all, it's public, so that means it's accessible everywhere. And this is also how Unity utilizes MVC to expose fields like this to the Unity editor. This guy is a mono behavior, so he can be attached to game objects. But now what we've seen is whenever a script is attached to a game object, that script is first, we create an instance of that script. So there is a somewhere in the Unity code, there would be something like pellet controller PC is equal to new pellet controller. That type of thing, which then allows us to say PC dot direction directly. So this would be somewhere else in the program. So we can get the direction of this thing directly because it is public. I don't need to have a getter to a function to call related to that. All right. Nothing says you couldn't have a function to do it. But what you're getting when you ask for the pellet controller component of a game object is you are getting the running instance of that script. All right. And it is that instance where they keep calling the update method every frame and so on and so forth. This is the way it's working behind the scenes. All right. So this would allow us, by adding this new ability, which is actually kind of an old ability, but it allows us to start thinking about our running scripts, our mono behaviors, as now being things we can use in our programs. You know, we can use with some of our logic because we're using it right here. We're asking the pellet controller, which direction is it supposed to be heading based on the dude it was attached to. All right, so back to my player controller. All right, so we're going to remove the pellet from the correct direction based on the pellet we actually ran over. I fixed the bug. I just put a little I removed the semicolon there. So if you did download my latest version of the code after class on Friday, I posted on Slack letting you know that the updated version of the code had this fix in it. So if you were to download it, you would have had an error right away to show you that line of code. So go back to Unity here. So now I should be able to run through my dungeon. The correct things are now gone. All because we're having the pellets report the direction where they were in a room. All right. Now, this is sort of kind of a trick, but I would say it's a pretty important trick. The issue where I didn't necessarily want to use this thing is I've kind of been advertising that things that are mono behaviors are specifically the Unity side of things. Things that are not mono behaviors is our back end stuff that we're using to keep track of our data, where you can actually use mono behaviors inside that back end stuff if you wanted to. It's possible to accomplish that. Not always the solution, but it can be a solution. And really, it's a pretty good solution for this type of problem. All right. Questions about being able to grab a script component and accessing elements of it. Keeping in mind here, there's a little bit of danger in that if I'm working with this script, this pellet controller script, start and update, these guys are normal functions that are non-static functions. So if I have an instance of the script, nothing actually prevents me from calling one of those functions. Or if I write other functions in here, nothing prevents me from calling those functions. I guess bottom line is that some of the security that we had where we just left mono behaviors set in the world of the Unity side of things starts falling apart a little bit if we now allow ourselves to externally call the update function, for example, rather than relying on the game engine to call it once per frame. You could just tell yourself not to do it, but there's nothing about the code that will prevent you from doing it. All right, so what we want to do here is we want to start working towards our fight scene. So we're going to go ahead and we're going to create another scene in our game. So we'll go into our projects, we'll go into our assets, we'll go into our scenes. So we have our dungeon room. These other scenes are not important, so I'm actually going to delete those. All right, and I'm going to create, I guess I need to go to File, New Scene. So I'm going to do File, New Scene. And I'll go ahead and do the basic built-in scene. That way it gives me the light and the camera and all that stuff. Wants to know if I want to save my other scene. I'll say yes, save it. So now I have my brand new scene here. I'll go in and save this guy as I'll save it inside of scenes, and I'm going to save it as call it try that again. The old college try. Call that guy fight scene. I'll put it inside of scenes. Save. Okay, so there's my fight scene. All right, so a couple of people are going to make a comeback here. So we're going to bring Chomp into this because that's our representation of our player, and the player is going to be going into this battle, right? All right, so we'll go into our Chomp game thing. We'll go to our prefabs. We'll go to our characters, and here's Chomp. So we'll throw Chomp out there. All right. Now I'm kind of visualizing this. Let me just kind of show you where I'm coming from this. Final Fantasy fight scene. Yeah, something along the lines of this guy where you come into the scene, your hero is over here, so this might be Chomp, your bad guys are over here, and then there's this back and forth fight until somebody kicks the bucket. All right, so that's what I'm modeling it after in my head. You can decide what makes sense for you. All right, so with that in mind, I'm going to go ahead and get Chomp rotated here. All right, so a lot of times what I'll do is I'll just start rotating him to make sure I get the right thing rotating in the right direction, and then I'll just put in the negative 90 degrees because that's the way it was turning. We could have also done plus 180. No, plus 260, right? And then obviously the bad guy is probably the pink guy. We'll rotate him a little bit. Oop. So that's 90 degrees. All right, so we have those guys sitting there facing each other. Um, we probably, now there are a couple different ways we can do this. We can say that we want to have like the hit points of our player, maybe on top of the player. If we go back to our scene here and we kind of think about this from an old school video game perspective, you know, the actual players here didn't have their like their number of hit points or anything above the person. Instead, it was part of the fight scenes user interface where they had some text down on the bottom to see this stuff. So that's, you can do that with a canvas if you want. Similarly, you can do that with text meshes, which we've done a little bit before. I think I'm going to kind of do that where I'll just have a couple of, you know, text boxes down there that show the hero and the monster and what their hit points are, and that way we can see them go back and forth as they are getting into fights. So we'll come back out here. Now I'll go ahead and if we click on our camera, we see that this is the way the camera currently looks. So we definitely need to make some changes to our camera. Right. So we probably can move these dudes a little bit closer together. All right. So something like that, if we were to run the game, is what that scene will look like. Trump looks like he could have an eye laser beam attack, I think. It at least seems possible. We have to, it's got to be a special super attack. Like he, maybe when the other guy's below 5% life, we can do like a Mortal Kombat finish him. All right. So let's get a couple of pieces of information out here. So I'm going to go ahead and click on Chomp. And then I'm going to go ahead and right. So I'm looking at Chomp there. So I'm going to go ahead and put some text by him. Now, I would say that if you're going to have the text on the entire screen, maybe the canvas makes some sense, but because we're just kind of, we're not going to be moving our camera around, we're not going to be directly moving our guys around, we can kind of put text meshes wherever we want. So I'm going to go to 3D objects. I'll go to a text mesh pro. It wants me to import the text mesh pro essentials into this project. All right, and I don't need the examples or the extras. All right, so there is, we're going to call this guy player HP. And for our sample text, we'll go ahead and say hero HP, and then we'll put a thing over there like that. And then where's my text size? It's already pretty big, so let's get this into the scene. Click on our camera and see that it's dominating the scene. So we can now shrink down our text. Even smaller. and drag. Oh, wrong guy. It already shrink this guy down some. We do want it wide enough that we can put a number in there. And we'll put this maybe right below our hero. And things are curved a little bit. The camera's at a little bit of a funky angle, but we'll call it good enough. Maybe I'll just drop the text down just slightly. See if this looks somewhat reasonable. Okay, we'll say good enough. I think technically because of the angle of the camera, the player's facing us a little bit, but you can mess with that if you want yours to look better. All right. Similarly, we're going to have a, oh, I need to stop that. We're going to have a monster HP. And I'm actually going to change the name of this a little bit. So we're going to call this Text Mesh Pro TMP. Just so we remember what kind of monster or animal these things are. All right. So we'll move the monster one over under the monster. We'll change its text to monster HP. Let's see what that guy looks like. A little more. Oop. Perfect. All right, good. Oh, you're stretching. All right, so now we have these text boxes there ready to deal with whatever's going on in this scene. We want something to control our fight. All right, so we're going to go back here. We're going to create a script. Now we're going to, our fight scene, we're going to have something like probably a game object this is going to be attached to. So we can either attach it to one of our dudes in the scene. We can attach it to one of the text mesh pros, anything that's a game object. We can even attach it to the main camera. If we want it hanging on the main camera, since that's always going to be there. But just for clarity's sake, I'm going to create an empty game object here. And we're going to call this guy fight game controller geo for game object. Again, just reminding me the kind of thing that is. All right, and because we're going to be writing a script that's going to be attached to this guy, we're going to make this a mono behavior. So I'll go into my mono behaviors. We're going to do a create C# script, and we're going to call this guy the fight controller. And then we'll click on our fight game controller, and we're going to add our fight controller to that guy. All right, so the fight controller is going to be the guy who manages the back and forth of the fight. Okay, so when it's the player's turn, the player will attack monster's turn, the monster will attack, keep going around and around and around in a circle until somebody dies. That'll be the cadence here. So we want our script to know about both of our guys, the monster and the hero. We also wanted to know about the text mesh pros so that we can update the text on those guys to be our updated number. Now, one thing we could do is we could have a second text box for each of these, or we could just refill in the entire text. I'm just going to have one text box per thing just to keep it simple. But if my monster hit point is at 10 and I'm going to drop it to 9, let's say, I would change the text on the text box to monster HP colon 9, then monster HP colon 8. I couldn't just decrement by 7, 8, 9, or 9, 8, 7, whatever, because I'll be overwriting the monster HP string part. All right, so let's go into our script and create public fields for these guys. So we'll go into our fight controller script. All right, and so we're going to have a public game object. We're going to have our hero game object and our monster game object. Then we'll have a public Text Mesh Pro is in a different no, we had it in a different thing. Where does he live? Community Text Mesh Pro. It's not in Unity Editor, maybe?
Just TM Pro.
Is it TM Pro in Unity? Oh, you think it's you think it's already a thing? Oh, there you go, like that. Yeah.
Yeah.
Okay. Well, seems like it doesn't actually need it. And already knew about it. Let's leave it out for a second just to see if it screams at us. All right, so we'll have TM Pro, we'll have Hero, HP, TMP, and Monster, HP, TMP. Okay, yeah, you do need the using. So it has access to that namespace. Still doesn't seem to be overly happy. So TM Pro is a namespace. Oh, so we have the namespace TM Pro, we have the variable type text mesh pro. There we go. So you do need using TM Pro because this is a namespace. This is a library where a bunch of stuff is. And inside that we have our text mesh pro variable type. All right, so let's connect these guys up. All right, so this guy is expecting our hero game object, and that's going to be our chomp. It's expecting our monster game object, which is going to be our ghost. It's expecting our hero text mesh pro. It's our player HP. and our monster Text Mesh Pro. All right, so now we have the ability to write to this scene. And of course, I left my code running there, so all that stuff I just did is going to get undone. Of course. All right. Did I at least keep my script? I did. So this is our fight controller game object. This guy will get a fight controller script. All right, I happened to copy the components before I did this, so I don't have to drag them back in, but all right. So we have those guys. Let's just test our text meshes real quick. Make sure we'll go into start. We'll say this dot hero HP text mesh dot text is equal to boo. Make sure it is doing that. All right, so we have control over that guy now. All right, so now we have to go back and look at our player. We're probably also going to need to create a monster. All right. Let's see. For the homework for today, you're just supposed to have a fight scene and have it show up maybe when we run into a pellet, something like that. Okay, so let's go just get that part set up here real quick. That's going to be in our player controller when we run into a power pellet. We're going to go ahead and load our scene, and we name the scene. We name it fight scene. Fight scene. That. Oh. All right. Now I think this is currently not going to work because I haven't added the scene to the build options, but let's just test that real quick. So I'll load up my dungeon room. We'll hit play. We'll hit a pellet where we're telling it to load the scene. Okay, so we probably got an error down there. We did. So we need to go into, is it file build settings? File build settings. We need to add some scenes to this guy. Actually, interestingly enough, so we can add our open scene, which is our dungeon room. Go ahead and stop that. And then I'm going to open up my fight scene. We'll go into build settings. And we'll add that guy. Back to our normal dungeon room and run into a pellet. All right. So now we have it loading a fight scene when a pellet happens, let's say. All right. Now, we might decide that, okay, the player only gets the pellet if they win the fight, unless we want to look at it from the perspective of, you know, if a player loses the fight, then they just lose the game. They get one life. You know, we can decide what that means. But the point here is that once we've loaded that new scene, previous scene is gone, right? So if we want to return back to that scene, we're going to need to remember the current state of that that scene. And remember, we were about to collect a pellet and that kind of stuff. Not necessary for the homework assignment that was due today, but more necessary for if we're going to have a fight here for the privilege of collecting a pellet and we win the fight, we already have the ability to go ahead and load the next scene, the next room, either go back into the current room they were in where they are trying to collect the pellet, or put them into the room they would have ended up in. We can decide which of those makes more sense. but at the very least, we need to have a mechanism for getting at that information once we get there. So we'll burn that bridge when we get to it, but keep in mind, we don't have that now. Okay. So now we need to give players, well, we need to bring monsters into existence, and then we need to make players have a number of hit points. So let's go in here. I don't believe we currently have player, or we don't have monsters yet, right? We can double check that inside of our scripts. Normal classes, so we have a player, but no monster. Okay, so what I'm going to do here is we're going to mess around with inheritance a little bit more, because we're going to say at their core, both players and monsters are both inhabitants. I think that's compatible with what we had done last term. So I'm going to go ahead and I'm going to create a script called an inhabitant. Inhabitant. All right. And I'll go into that guy. First thing I'm going to do is I'm going to get rid of it as a mono behavior. So this is an inhabitant. Then I'm going to make it an abstract class. What is abstract? What is an abstract class again? And why would I make inhabitant an abstract class? What am I trying? What do you suspect I'm trying to do here? Why have I created a class called inhabitant with the it's not extends in this language, it's this, with the goal of having a player inherit from inhabitant. So remember, an abstract class says you cannot create an instance of this class. So inhabitants will only exist, similar to what we did with our pellets, will only exist as a result of having players and monsters. But we're going to say that all players and monsters have names, therefore all inhabitants will have a name. So I'm going to remove that from player. I'm going to put the name into inhabitant. Now, why can't I leave that as private right now? What does it mean for a field or a any member of a class to be private? And why is that not going to work here? Nothing. Nothing. You participate as much as my grad students. Go ahead. Yeah, we got to be inside the inhabitant class. And we probably are going to want to be able to access our name variable inside of players and monsters, right? So we need to loosen the reins a little bit, and we'll make this guy protected, which allows us now to have access inside of children of this class. Not to everybody, but children of this class. All right, so we'll say inhabitants have a name. All right, we're going to go ahead and create our constructor for inhabitant. And we're going to say inhabitant takes in a string S like that. And we'll say this dot name is equal to the name that was passed in. Oh, sorry. All right. So those guys are now connected. So now we need to go back to our player and make sure when a player is born, an inhabitant is also born. And if you remember, we did this with our pellets. We did it with our, so our pellet was an abstract class. So when we created our, what kind of special pellet did we make? Armor pellet. So our armor pellet, it took in, it had a, this is how it calls the parent's constructor. All right. So we want to go ahead and do that. Remember, our parent's constructor in this case takes in a string. So when a player is born, where's my player? The player constructor takes in a name. We're going to take that variable name and pass it to our parent's constructor, which is going to be our constructor for inhabitant. All right, this is how you would do it in C#. If we were in Java, we would have said super name, and it would have had to be the very first line of our constructor inside of player. That would call the inhabitant constructor first, setting up the baseline for this guy, and then we would differentiate ourselves from that point forward. So personally, I think I like the keyword super better than base. But technically base is the base class. Although I do think I like the syntax of this guy being up here better, because it's, like I mentioned in Java, that thing has to be line 1. It has to be the very first thing you do inside of the child constructor. This forces that syntax. Okay. So whatever. So when we build it, when we build a player will take in a name. It'll pass that name to its parent constructor. So then we no longer need to set the name in here. All right. But what we're going to say is, well, now we need to ask ourselves, well, we also have monsters, right? So a monster at this point is going to be very, very similar to a player. In fact, in many cases, identical to the player. We haven't differentiated monster from player quite yet. We'll get to that. But let's go and create our monster script, our monster class. So this is going to be inside of our normal scripts. So we'll create a C# script called monster. We'll go into monster here. It's no longer going to be a mono behavior. Instead, it's going to be an inhabitant. We'll get rid of the start and update functions. It's no longer a mono behavior. And we're going to go ahead and basically make this the same. We're going to say private room, what do I call it? Current room for player. Yep. Well, let me ask you this. Do players and monsters all have a current room? At least potentially. It all depends on whether or not we want monsters to be able to travel through our dungeon. Like right now, we're bumping into a monster, but what if a monster bumps into us? We start having the monster travel through rooms in our dungeon, and we're just standing there minding our business, and all of a sudden a monster comes wandering in, picks up one of our pellets, so he gets an armor boost. Or what if he gets one of those fireball ones we haven't invented yet? That'll be even worse. Okay, so with that in mind, if all inhabitants have a current room, we're going to take current room out of here as well. We'll go and put that into inhabitant. I'm going to drag player down. Can I not do that? Does it not let me just drag it down? Oh, perfect. That's exactly what I wanted. That's what all right. So an inhabitant will have a current room. We'll make that guy protected as well. We'll make this dot current room equal null. So we'll do that setup inside of inhabitant, which then means inside of player, we no longer need to do that in here. Similarly, current room, set current room, these are things that are available to all inhabitants, right? So we're going to move it out of player. We're going to put it into inhabitant. We'll keep these public because we want everybody to be able to call, ask an inhabitant, what's your current room? And right now, things that have an is a relationship with inhabitant will be players and will be monsters. So anything that's a player or a monster will be able to, we'll have a name, we'll have a current room, and we'll be able to ask it, what is your current room? And we'll be able to set the current room. At this point, we have no way of actually getting the name of a player or a monster because we've kept that locked down. Well, externally to player or monster. A player can find out their own name because it's protected. A monster can find out its own name because it's protected. But outside of this, if we are inside of a room or something like that, if we have an instance of player, we cannot get that player's name currently because it's only accessible inside of inhabitant, player, and monster. That's okay. We don't need it yet, so we'll just leave it like this. So now we've moved the abilities of getting and setting the current room into inhabitant. We've taken that out of player. So at this point, really, players and monsters are basically nothing, right? So here's our monster, same thing. We'll have our constructor for monster. This guy will take in a string name. And we'll pass that to our parent constructor. All right, so now we have monsters and we have players. And we should be able to go back here and see that we have not broken our code. Because players and well, we're not even using monsters yet, but players, even though we were using them before, they don't have any new abilities. We've just moved several of their talents into inhabitant. All right. So keynote. This guy. All right, so for homework, we want to update the fight scene such that the player and monster take turns attacking each other. Maybe an attack involves moving slightly toward the target. So a player might just move in a little bit towards the monster. The monster might just move in a bit towards the player. Once they're done attacking, they move back, something along those lines. You can decide if you want attacking to mean something different, but in the old Final Fantasy games, your guy would zip in and then he would do like a little sword attack thing or a magic thing. So we'll do a little animation probably next time for that. If you want to look into it, animations aren't hard. It's just another component you put in there. But in any case, have some sort of way of visually showing the who's attacking. All right, so update the fight scene such that the player and monster take turns attacking each other. Maybe an attack involves moving slightly towards the target. And an attack rolls a 20-sided dice to determine if the attack hits. I'm going to do this here. So all inhabitants have an armor class, which must be cleared in order for an attack to hit the inhabitant. So we compare the D20 roll against the target's armor class. And if it is larger, the target is hit. The damage done should be a random value on a 6-sided die. That is 1 to 6. And should be deducted from the HP of the target. Repeat until someone dies. And show who the victor is some way. All right, so players and monsters will both have to have hit points as well as armor classes, probably randomly generated. And then when you attack, you'll go back and forth, rolling the dice, find out, do you hit? If you hit, find out how hard you hit. That dude takes damage, then he comes back at you. Keep doing it over and over and over again until somebody dies. Make some sense? All right, I'll see everybody on Wednesday. Remember, Friday this week, we're off for Easter. I won't give you homework over Easter break, so that's why I made this assignment maybe a little bit bigger. I'll update my code right now, so you'll have it. I'll see everybody on Wednesday.
So, I'm taking my glasses next year.
Mm-hmm.